Welcome to Tech Tuesday. Today we're going to be discussing the Honeywell HC900 hybrid controller. Today's session is being recorded and it will be available on YouTube. So please visit our YouTube channel at Loy Instrument, and you can review the slides and the training that we're going over today. You can also access this through a LinkedIn post that we'll have later on today. And at the end of today's session, we'll have questions and answers, and we'll help answer any questions you might have. And so let's get started. The Honeywell HC900 hybrid controller, we're going to be discussing that today. Some of the things that we're going to be going over today. We're going to first start with the CONTROLEDGE HC900. We'll get into the hardware and specifications, software. We'll talk a little bit about some vertical markets that the HC900 plays real well in. And then we'll dive down into a couple specific applications within those vertical markets so you can see how the HC900 applies to different areas in these plants. The CONTROLEDGE family includes a couple different products. Today we'll be discussing the top two products, which is the HC900. The HC900 can be used in both process control applications and also SIL 2 rated safety applications. We're going to get into both of those applications a little bit later here in the training. The bottom products here are the CONTROLEDGE PLC. So you can do straight PLC control, ladder logic, function block, very high or very fast logic control, which matches up with all the PLCs on the market. The CONTROLEDGE RTU, which is a product that's used in remote I/O or remote process control applications. Some of these would include pump houses, wastewater, maybe there might be a combustion skid or another skid that needs remote I/O, and the CONTROLEDGE RTU serves those needs. And then last but not least, on the far right-hand side is the CONTROLEDGE UOC, which uses all these UOC and the PLC use the same I/O as the HC900, but the UOC CONTROLEDGE can live in the same world as the Honeywell DCS system, which again we'll discuss a little bit further here in the coming slides. The next slide up here shows a little bit about the HC900 CONTROLEDGE family. Again, if you move from left to right, the base functional unit would be the CONTROLEDGE RTU, again used in remote applications, remote I/O. It has a very low power consumption of 1.8 watts, so it can be used in applications where you might have solar panels, battery operated systems, powering up the RTU, applications where you might not have access to local power. It also has a lot of different communication options to it. So it has Modbus, DNP3, HART protocol, and also Ethernet IP. This allows the RTU CONTROLEDGE to be able to communicate to field transmitters that utilize these communication protocols, or it can talk to third-party devices and gather information and use it in the control scheme. It also has the local storage via SD card, so you can store trend files or other trending information into the CPU, and then later on take the SD card out and take it to a computer system and be able to view the trending data. This is also able to, you'll see a common theme up here on the very top, this Experian HS. Experian HS is the Honeywell SCADA system, so this is a software system that resides on top of the control platform and allows the operator to gather trend information, see live graphics of the process control, and being able to have a window into the process control to be able to manipulate set points, look at process variables, and do other real-time tasks that the operator might have. So the SCADA system is known as Experian HS. We're not going to get into that on today's training, but in a future training session we'll dive into that a little bit more. The next one up is the ControlEdge HC900, and this is known as the hybrid control HC900. This controller will take process control, logic control, and safety control, and embeds it into the CPU as a hybrid control system that allows control over all three of those processes or those areas. This typically is used in SIL applications that require burner management systems. So it's FM, NFPA 85, 86, and SIL 2 rated. It has a universal I/O, so it allows you to configure the I/O card for inputs and outputs. Universal in the scheme of being able to choose between many different thermocouples, RTDs, voltages, milliamps, and it allows for a nice compact card that has all the different types of inputs and outputs. This system will also communicate Modbus TCP, also OPC UA. So for third-party devices that you want to communicate to the HC900 system to share information back and forth, it allows a real nice versatile communication path to be able to do that. In many applications that utilize that type of communication protocol, we're taking the HC900 and communicating to either the Honeywell paperless strip chart recorders, circular chart recorders, actuators, in some cases transmitters. We recently did a project where we have some safety LEL gas detectors which are communicating Modbus into the HC900, and it really allows a nice bi-directional communication path to share information without having to utilize the I/O cards on the HC900. The perfect application for the HC900 is if you have a system that has 4 PID loops or more, along with trending requirements, recording requirements, or in addition I/O, which you're using for discrete control. The HC900, that's really a perfect fit for that product. The next step would be the ControlEdge PLC if we're moving to the right. The ControlEdge PLC utilizes the same rack and I/O cards as the HC900, but allows you to program it in ladder logic, sequential control, or function block, and offers a nice transition for customers that are going from an older PLC upgrading to a newer PLC, and it operates in that PLC environment with doing very fast discrete control. Moving to the right-hand side, when we get up to the Honeywell Control Edge UOC, this is utilizing still the same rack, the same I/O cards, has a different firmware loaded in the CPU. This controller right here will live in the same environment as the Honeywell DCS system, which is the C300 controller. So the UOC utilizes the same control platform and configuration as a DCS system, and that lives within the CPU for a distributed control system. This application right here is mostly like refineries or other applications that have an existing Honeywell DCS system, and the customer is looking to upgrade maybe an older PLC architecture, but still wants that DCS type functionality. And the Honeywell Control Edge UOC will accomplish that for the customer. Moving over to the right, the C300. This is a little bit different hardware architecture. You can see the C300 I/O cards up here on the top where my cursor's hovering over. The C300 is a true DCS system that again is used a lot in the large refineries, chemical facilities, pharmaceutical, sometimes in power gen, but these are distributed control systems that have I/O through the entire plant, and with a common SCADA system which is called Experion LX, which is basically the Experion HS on steroids. So it's a very large system, SCADA system that can control an entire plant. On these larger systems, instead of just having the CPU as a redundant, it also has the I/O architecture redundancy built into it as well. So today we're going to focus on the HC900. Future training sessions we'll move into some of these other products, but the HC900 really serves a nice modular control platform for a lot of applications, which we'll take a look at here in the coming slides. We talked a little bit about the I/O and the CPU on the HC900. The HC900 has a capability of having SIL2 rated CPU and I/O. Most of the SIL2 rated systems are used in burner management systems, spill prevention, ESD, environmental type applications, and a lot of customers that require that SIL2 will move in that direction. It seems today more and more applications are requiring the SIL2, especially if you get into chemical, wastewater, refineries, things of that such, which requires a little bit different level or a higher level of security. Most customers will tell you that they're either requiring SIL2 or SIL3. Most of our applications are in the SIL2 rating. The safety and non-safety I/O and CPU can live in separate systems, so some customers will actually separate out these two and have the safety system just taking care of those areas or those parts of the process, and then the other process control environment, which doesn't require the high level of security, they'll have that separated out into a different architecture. Both of these systems, if they're separated out, will look as if they are one system as they communicate up to a SCADA system or the HC900 control station. So it looks as basically one common platform when you're viewing it at that level, but down at the I/O level they separate it out and allow these CPUs to communicate across the network and sharing information between the two systems. There's also some systems that customers allow both the safety and non-safety I/O to reside under the same CPU, and this is the kind of the universal nature of the HC900, that you can have both safety I/O and non-safety I/O living under the same control architecture and having both of them operate separately to to control those two different areas. So let's talk a little bit about the hardware features of the HC900. On the far left, you see the CPU or the power supply. This can be 24 volts, 120 volts, 240 volts, universal power supply. Moving on to the right, we have the CPU. The CPU comes in a couple different options depending on how many communication ports you need and also how many or how much memory you need in the CPU. So it starts at the C30, moves up to C50, C70, and then C75R. Based on the memory requirements, you'll choose the CPU that best fits your application. On the CPU, it has two RS-232 or RS-485 ports. These are basically just a three-way communication link which you can take out to a recorder, you can take out to a third-party system, or maybe another device like an actuator or a transmitter that communicates Modbus. These two ports here can be used for applications where your communication link is maybe across the plant, maybe distances of 1,000 to 1,500 feet away. And this allows you to share information back and forth with the CPU and field devices across that Modbus network. If you want to use a Ethernet port, so you can have a couple different options here for Ethernet. You have the very top one, which is your Ethernet E1 port, and this is used for communicating up to like an Experion HS or LX SCADA software. It could also be used to communicate up to like a SpecView software or maybe a third-party software like Wonderware, something like that. But you can use that to communicate up to your supervisory level software. You can also use it for peer-to-peer communications. So if you had several HC900 CPUs out on the plant floor and you wanted to share information back and forth between processes so the operator could see all that data on one display, you can have the peer-to-peer communications accomplish that for you. In addition, on that same port, you can also have a HC900 control station, which comes in either 10-inch or 15-inch, hooked up to that port, which would allow communications of all the process variables, alarms, diagnostics, things like that, that communicates up to the local display. The very bottom port is for the remote I/O. So you can have additional remote racks hooked up to the single CPU, and if you have processes that are spread out through different areas in the plant, you can have one CPU communicating to these additional racks that would allow the I/O to reside next to the process. So it'd be a little bit easier for troubleshooting, diagnostics, and doing work right at the local piece of equipment. As we move over to the right-hand side, you have now your I/O modules. You can have a 4, 8, or 12 slot rack. Each one of the slots start with the very first I/O card, so that would be slot number 1. These boards can come in many different flavors. You can have analog out, analog in, which are both universal. You can have digital in, digital out, dry contact. So there's a lot of different versions or variations of those I/O modules that you can have in the rack. The one really nice thing about those I/O modules is if you need to replace one for some reason, you can actually replace those under power. So it's a hot swap, they call it. And all you need to do is remove the card, replace it with the new card, and meanwhile have your CPU up and running, and you don't have to reboot the processor when you do that. That's kind of a big thing, especially if you have a process that can't live with any downtime. Replacing I/O under power is a big thing. The other thing that makes it really nice when you replace these I/O cards is that the terminal block on the very front here has a top screw and bottom screw. You can leave all your wiring left on the card, and then all you have to do is remove these 2 screws, remove this terminal block, and then pull your card out, put the new card in, and then replace the terminal block. This saves a lot of time, a lot of downtime, because you don't have to worry about rewiring the card when you put a new one in. On the terminal covers, it has a little paper insert on the back as it shows you all the wiring as well, so you don't have to worry about thumbing through a manual to figure out which wires need to go where. So it offers a really nice, easy to use wiring schematic so you can wire it up. Each one of the I/O cards also have this I/O status LED. So along the right-hand side, you'll have a status LED if the input is good or bad. So you'll have a red or green indication. And then also at the very top, you also have an LED indicator that shows if the card is good or bad. So there's some very quick diagnostics that you can get if you just look at the front of the HC900 without getting the software connected to it. On the far right, we have the HC900 display. Again, this comes in 10 or 15-inch display. It is touch panel, although you do have some buttons on the older style here that you can actually configure up and use these as buttons for accessing certain displays. Honeywell has come out with a new display that removes these buttons and allows you to configure soft buttons on the left-hand side. Physically, it's the same display, it just removes these buttons on the left here. The display has a lot of CAN displays that reduces a lot of engineering time out of the box. So when you get this display, it has preloaded all of the displays that you would typically use for HC900 process control. And this would include PID loop displays, trending displays, set point programmer displays, and a lot of other ones out of the library. The nice thing about the display is that the only thing you really need in order to allow communications to happen between the HC900 and the display is to upload a tag file out of the configuration of the HC900 CPU. It's imported into the display, and then from that point you have a complete set of tags and points that you can then use within the display to build different views into the process. And that really reduces a lot of engineering time, because you're not having to waste a lot of time building your own graphics. So you can use the ones that are resident in the display and get up and running in a very quick manner. It also has pre-built displays for a lot of diagnostics that you really don't get with other manufacturers. The display will actually go all the way down to the points on the I/O cards and tell you not only if there's a diagnostic issue, it will also tell you the firmware revision and the part number of the display, so that if you do need to replace it, you can have that part number handy to give to your local distributor. The enhanced new SIL Universal I/O is really a differentiator out in the market. This offers 16 channels, SIL 2 rated, 1 millisecond scan time. You can do voting and validation for safety shutdown applications, line monitoring features, short circuit protection for individual channels. So each one of the channels are isolated from each other, so that you don't have, if you have one channel that fails, it doesn't jump over to all the other channels and fail the entire card. This can be configured for multiple universal ins and outs on the single card. So instead of ordering two separate cards, one for inputs and one for outputs, you can actually use just this one and do all that into one board. So this reduces a lot of additional I/O that you might have to order for your project. We talked a little bit about the diagnostics that's on board on this HC900. As I stated earlier, the diagnostics go all the way down to the board level, and it shares that information through either the configuration software or through the display that you have hooked up to the or to the I/O rack. This will allow you early detection of sensors if they're going to fail. So there's an early detection on, for example, thermocouples. The detection system will actually sense if there's a failure that's about to occur but it hasn't occurred yet, and this will save you a lot of downtime, because you can replace your thermocouple before it actually fails. The other big thing on each one of these cards is it has a history backup. So, for example, if we had this HC900 communicating to a SCADA supervisory software package, and let's say the communications between this rack and the software was to fail, once it becomes live again and everything's back up and running, the HC900 will take all of the history data with the trend charts and things of that nature, and it will backfill all those data points into the SCADA so that you don't have any missing data. And it has onboard memory on the CPU that allows that history to be stored on the CPU for later retrieval. The I/O topology for the HC900, there are some applications that require a couple different types of topology. Just know that the HC900 can work in either a star or a ring network topology. We discussed this a little bit earlier, but the same I/O modules are used for both process and safety, and the same I/O modules are used through the different platforms of the HC900 Control Edge family. So whether it be the PLC or the UOC or HC900, they share the same I/O cards so that you can reduce inventory costs in your plant. Let's talk a little bit about the software that's used to configure the HC900. The nice thing is on this software, it's one common software tool that's used for both process and safety configuration. So it'll help reduce training costs when using the HC900. It also reduces a lot of engineering time and cost as well. The HC900 tool, we've heard from customers that it's able to reduce engineering time by 10 to 15% using this one common platform that is used to not only configure the safety I/O, but your process control, your discrete control. It's all offered under one software package. The HC900 utilizes function block configuration. And it has a lot of tailored blocks, which we'll discuss in some of the applications that allow you to drag and drop a function block for a specific application where you don't have to waste time building your own control scheme. You actually pick from a library of function blocks to use in your control architecture. As you can see on the right-hand side, this is the layout of the configuration tool. So you have your function block on the far right-hand side, and then on the left-hand side, you'll have your function block library. There's been a couple additions over the last couple of years that allows this tool to be even more user-friendly in the fact that once you build your control scheme on the right-hand side, you can save that control scheme into the library. So later on, if you have another application in the plant, or if you're an OEM that has another similar application that you want to program, all you have to do then is pick that control screen from the left-hand side and drag and drop that whole application onto the page, and you have your configuration completed. So that allows for obviously reduced engineering time there, because you only have to build it once and you can use it over and over again. It also allows online monitoring of the system. So the same configuration tool is used for assisting in troubleshooting and diagnostics, because you can have the software communicating to the HC900 real time, and you can watch all of the analogs and the digital values, and actually the softwares between the blocks go live or go offline when they're not utilizing that control scheme. So for startup and troubleshooting, this is a very powerful tool because it allows you real-time data as you're trying to start up or troubleshoot a situation out in the plant. The function block, you talked earlier about the different CPUs on the HC900, and depending on the CPU that you're using, it has a memory storage in there that allows you to configure a certain amount of function blocks on the configuration. So as you can see, the C30 allows 400 function blocks to be configured, a C50 is 2,000, and then when you go up to the C70 or C75 CPU, now you can have 15,000 function blocks configured. I will tell you that a program that has 2,000 function blocks, that's a pretty intricate system. Most applications that I've come across, are usually around the 500 to 1,000 function block range, but you can see the capacity here. You can really do a lot with the single CPU. The hardware that you have in the HC900 can complement over 4,608 I/O and up to 12 I/O racks. We talked about the remote I/O racks or additional I/O racks on a CPU. You can do up to 12 off of the one CPU. For larger systems, this will help reduce the overall cost. We were talking a little bit about the online maintenance. So obviously you can edit in runtime mode. That's another big thing. If you wanted to add, for example, this block over here on the right-hand side is an analog input block. And let's say, for example, you're doing an application, you want to add another thermocouple to the appliance that you're controlling. You can do this in runtime mode, so you can add your function block, you configure it, and then once you save it and download to the CPU, it'll actually give you a choice between either hot start or cold start. For a hot start, it will take your configuration that you changed, it will store it into memory, and then on the next scan, it will actually put that new control algorithm in run mode and will not allow the CPU to shut down. So there are a lot of different PLCs and a lot of different manufacturers that will actually require you to do a cold start, which then takes down the whole process, and you'll have to shut down your system, and then you'll start it back up, and that requires some downtime there. So this is a very important good tool within the HC900 that allows you to do configuration changes and go to a hot start. A couple of the other features of the software that's very important, especially in process control. The process control loop will allow you to do auto tune. It'll also have the standard fuzzy logic, and the fuzzy logic prevents the overshoot of process. This app actually operates separate from your tuning, and it gives you a little bit more of an advanced type of online tuning, which allows for very quick control that allows you to come back to set point, and it minimizes any overshoot or undershoot of that process variable, so that it keeps real good quality control of the process. This is an example of the PID with fuzzy logic. So you can see on the far right hand side, this might be pretty typical of a normal PID loop where you're coming up to temperature, and then once you start trying to line out at the set point, you might have some corrections that happen in the process controller in order to later on line out at your set point. On the left hand side, if you have fuzzy logic in some applications, it allows that PID loop to come up to set point and very, very quickly assess where it needs to be and lines out at set point very quickly. So this is fuzzy logic, which is a standard feature in the HC900, and you can either enable it or disable it, but it's a nice feature to have to increase productivity and quality. The tool is very easy to use. Like I said, it has custom libraries, so you can replicate configurations very quickly out of the custom library. You can also do bulk editing. You can do search and replace. You can copy and paste certain function blocks into other areas within the configuration. There's also firmware revision control. Or revision control in the configuration that you do. So you can very quickly jump back and forth between different revisions of your control configuration that you've, and be able to very, control that revision and see the changes that you made over a certain time period. Point Builder utility is another thing that offers very quick configuration. If you're using a SCADA software like SpecView or Experion, HS, EBI, LX, any of the SCADA packages that Honeywell might have. What this allows you to do is once you've built your configuration into the HC900, there's an export tool, so it exports all of the data tags to a CSV file, and then later on you can import that into the Honeywell SCADA system, allowing you to build all the points very quickly without having to go through all the individual data tags and rebuilding them. Again, this saves a lot of time in engineering. Some of the different applications that the HC900 really shines in, metals and mining. We've done a lot of heat treat applications within this area. Loy Instrument has done a lot of vacuum furnaces, burner management, thermal oxidizers, process heaters, vaporizers. There's a ton of applications in the combustion arena that the HC900 really works well in. And this is an application that we've used a lot within Ohio and Indiana, Kentucky. The chemicals, pharmaceuticals, so it's great for process control in those areas. In some of those applications, incinerators, process heaters, vaporizers. The refining applications, pipeline monitoring, spill prevention, emergency shutdown. These would require a lot of the SIL 2 rated HC900s. And as you can read through the bottom there's a lot of other applications in different industries that the HC900 works really well in, especially if you're marrying process control with discrete control. The HC900 is really going to outshine a lot of other competition in these areas. Some of the safety applications, again, these safety applications are in heat treatment, burner management systems, combustion control, pipeline monitoring, spill prevention, emergency shutdown. Like I said, a lot of the applications that the HC900 really shines in is furnace, boilers, preheaters, kilns, ovens, reactors, dryers, thermal oxidizers. So there's a lot of thermal applications that it plays real well in. A lot of the critical control, these would get into applications for electronics, semiconductors, cement, glass, and textiles. These are areas where the process control is very critical, and you can't have much overshoot or undershoot of your process control. And this is where the fuzzy logic and some of the advanced tuning comes into play with the HC900. We talked a little earlier about some of the specific function blocks for different applications. This is a very powerful tool because if you're an OEM or if you're an end user with a heat treat facility that has carbon potential control, there is a function block in the library of the HC900 that is specific for that application. In other PLCs, other manufacturers, you have to do a lot of extra configuration or multiple function blocks to accomplish this one task. But in the HC900, this is a standard function block that you can pull out into a open configuration worksheet and really within no time at all configure a carbon control loop and be able to get up and running. So for carbon potential applications, this function block, if you click on it, it goes into this configuration worksheet on the left-hand side, which gives you a lot of the standard tabs to configure different ranges, different inputs into that function block to accomplish that control. You also see that down here it has O2 probe manufacturer. If you click on that block, it will actually give you all the O2 probe manufacturers like Super Systems and others that you can then pick from that selection, and the carbon control loop will then understand the input that's coming from that probe and be able to use it in that control algorithm. Another out-of-the-box function block is the dew point control. So again, this would be for more of the heat treat applications. You can see down here on the bottom where it says O2 probe manufacturer. Again, you can select the probe manufacturer from several different companies. You select that, and then the dew point control block will understand what the probe is that's hooked up to that system. You can see that it talks about typical dew point levels, dew point versus surface carbon percent, and this algorithm is used a lot within the heat treat applications, and it really enhances the level of function or functionality that you can have for that application. Set point program, again, type of function in a standard PLC or other control, you would have to use multiple function blocks or multiple configurations to complete this task. But in the Honeywell world or the Honeywell environment, they offer you one block that's a set point programmer, and this is used widely for batch type applications where you need to ramp and soak the temperature or process variable over a specific time. You can have up to 99 profiles stored within the HC900, and you can have up to 50 segments within each one of these set point profiles. You can see that there's a whole lot of functionality here that allows you to store all of those profiles under one process controller and one simple function block to accomplish that task. The control display on the HC900 also has a very nice display that shows you the process version set point of your set point program profile, and it'll actually pre-plot that set point profile for the entire program, so it allows the operator to look at the display and verify that they have the right profile loaded before they go ahead and run it. That tool right there is pretty powerful, and like I said, for somebody to build a display like that would take many engineering hours, but with the HC900 display, that's out of the box, ready to go, and all you have to do is import the tags with a small amount of configuration and you're up and running. We'll dive into a couple different applications here. One is a boiler application. The HC900 really fits well into package boilers and large utility boilers, and it offers process control for many different areas in the boiler and servicing around the boiler. So as you step through these, coal and ash handling, drum level, obviously combustion control, feed water flow, blow down control, boiler pressure control, superheater control, feed forward steam pressure control, furnace draft, steam temperature control, and flue gas, and then last but not least, the excess air. All of these applications require a pretty intense process control along with discrete control, and the HC900 really performs well in types of applications. So the products that we use a lot for the boilers, obviously HC900 is one of the main ones, but then the other products within that family that we discussed earlier, the ControlEdge PLC, Experion LX and HS, which are your software SCADA systems, ControlEdge HC900 with SIL2, and then obviously the local operator interface, which is the 900 control station, or a panel PC use the Experion LX or HS software residing on it. The modular system, as we move over to the right-hand side, we're talking about out-of-the-box functionality with the control scheme within the HC900. There's a library that you can build for fuel air ratio control and O2 trim. So on some of the smaller package boilers, Honeywell used to have the control links or another PLC that might do the fuel air ratio. The control links is basically end of life on that product has come to fruition, and the fuel air ratio control can now be done in the HC900, replacing the control links with the Honeywell RM7800 series flame relay, or doing the SIL2 combustion control in the HC900. It also does the drum level control, feed water flow, and does this with very accurate PID. It's excellent temperature control, usually within plus or minus 0.5 degrees of set point, which is a very tight control, and also offers boiler master and firing rate control. On all of these boilers, since the HC900 does have the SIL2 rating, you can do all the burner management through the HC900, reducing components that you might have to have in the panel, and doing all this under a safe SIL2 rated single platform HC900. In the past, to do this type of burner management control, you would have your PID loop controller, and then you would have a flame relay or a flame safety burner management system as a separate entity. In the HC900, you can do all that in one. We were talking about the three-element control. So as you can see on the far right-hand side, this is a control architecture, function block architecture that you would have in the HC900. that would allow you to build a 3-element control system. And as you can see, around this function block is a description of the final control elements and the sensors that you would have leading into that application. So you would have your level, your steam drum level, feed water that goes into that drum. You might have a motor or a valve down here that you're controlling. You might have a flow transmitter here that's feeding that flow of that feed water back into your control system. So what's nice about this is that you can build this, save it into your library, and then when next time you want to do 3-element control, you would select it from the function block library, drag it out into your configuration, and literally within seconds you have a 3-element control system. So this obviously reduces a lot of engineering time with that function block library. The next application within boilers would be a boiler master or submaster. This would be where you have one plant master control system with the main steam header pressure controlling several different boilers and bringing the boilers on and off when needed. Also accomplishing your fuel-air ratio control down here on the bottom slide of this architecture. So you have an analog input coming in, which is your main steam header pressure. And the way that I know that this function block is an analog input is over on the left-hand side, you see it says AI. That stands for analog input. So at a very quick glance, I can see that that's an analog input. If you move down through this function block, you'll see 0401. And as I configure my I/O on the rack, this tells me where this analog input is hooked up to or wired up to. So on this one, it says 04 is rack number 4, and it's the, I'm sorry, this is the analog input card number 4 and the channel 1 on that analog input card number 4. So if I had a 4-slot chassis, that would be I/O slot number 4 and then channel 1 on that card. As I program these function blocks, you'll also see on the far right-hand side a number. And that number is a sequence order that I'm scanning. So as I program these, this might be the first function block I programmed. It has a number 1. The PID block might be the second one I programmed. That's number 2, and 3 and 4. The nice thing about this is that for some reason, if I wanted to go in and reorder that sequence scan, I could come into any one of these blocks and reorder it so that I could actually have the configuration scan a more important block first before I scan any of these other ones. In this scan order, it really makes sense because I want to scan my analog input before I go to my PID loop, and then last but not least would be scanning my analog out or control output out of that loop. Also in these blocks, you have several pins, inputs and output pins. These do not need to be all connected within the configuration. These are just functions that you can use to hook up. Maybe I want to hook up a digital output to an alarm. Maybe I want to retransmit a working set point. There's a lot of different pins here that give you functionality to either retransmit or feed a signal into this function block from somewhere else in the program. Fuel-air ratio control. This is one that we do quite a bit for combustion systems. And what this does is it gives you the best combustion efficiency at the optimum air to fuel ratio controlling, and this provides the highest level of efficiency for your burner system. And this offers, again, you can see over on the right-hand side, a fuel flow input, and we're actually square rooting that input so to give us our flow, and that's a pretty typical configuration if you just have a raw flow value coming into a control loop. And then you have your airflow coming in on another analog input, both of these feeding into a PID loop block and then sending an analog output signal. This is pretty typical for a fuel-air ratio system, and as you can see, If I double click on this PID block, again, I have tabs along the top that allow me to go in and configure that PID block to serve my application needs. So last but not least, I mean, we've talked a lot about enhanced safety. The HC900 is really used in a lot of different applications for enhanced safety. As I stated earlier, it's used a lot in burner management systems with combustion systems. Now, also outside of the HC900, there's a whole lot of other HC900 or Honeywell control products that offer that enhanced level of safety as well. Up in the top left here, this little blue box, that's an RM7800 series that offers a sill-rated burner management system, flame safeguard system. You move over to the right-hand side, you have this Honeywell transmitter that also has a sill rating for doing pressure, flow, level type applications. Obviously, HC900, which is the star of the show today, has a sill 2 rating. You move through the next component here. This is a gas detection or gas transmitter that senses LEL, O2, a lot of different types of gases, and that is also carries a sill rating, along with a UV detector. This little purple can here is a self-checking detector, and then last but not least, the valving that would be your safety shutoff valves on the gas train. The Maxon valves can offer up to SIL 3 certification for delivering gas to the burner. So you can see that Honeywell is very serious about safety. They have a lot of components here that complement the HC900 system that can be offered in a package to accomplish higher levels of safety out in the plant and the process area. So that sums up the HC900 today. You know, as I said, HC900 is great in applications where you might have 4 independent PID loops or more, along with trending and some discrete I/O control. And it really merges all of those different 3 areas into one nice small HC900 rack platform that accomplishes the control very well. We use it in a lot of applications, and customers through many different industries have enjoyed that tight process control that the HC900 works day in, day out. With that, do we have any questions from the attendees today? All right, so this concludes today's training. I will have this recorded and put on our Loy Instrument YouTube page, so you can go to that YouTube page and watch this at your leisure. And with that, we'll conclude today and hope to see you next Tuesday. As a reminder, we have the Honeywell demo trailer that will feature the HC900 and other items that we've talked about today in our Indianapolis headquarters on October 23rd, Friday, October 23rd. So if you have time and you'd like to stop by and talk to some Honeywell specialists and Loy Instrument specialists about the product or your application, feel free to stop by. Thanks for your time today.
Thanks.